Welcome to Ask and Learn.
So we have a bunch of positive charge on the y-axis with a linear charge density of 2 microcoulombs per meter, and that just runs all the way down here. And then there's a dipole 25 centimeters out, and it makes a 35-degree angle with the x-axis. So like this. And we have a charge here and a charge here, and they're both, one's positive 10 microcoulombs, one's negative, and they're separated by 2 centimeters. So now, ultimately, we want the net force. So first I'm going to figure out the potential energy of the dipole, which is negative P dot E. And since we know the angle, so E is the electric field, which is pointing this way because we have a bunch of positive charge. So if this is E, and the dipole is pointing this way, so this must be the positive 10 microcoulombs, then the angle is 35 degrees. So we can say this is the product of the absolute values times the cosine of the angle between them. Or I'll just say theta for now. So we can even simplify this further to get some quantities we know. The dipole, the magnitude of the dipole is the charge times the separation of the two charges. And the electric field from a line charge is going to be the linear charge density over 2 pi epsilon naught r. Okay. And r in this case is the x-coordinate. So this is going to be minus q d lambda over 2 pi epsilon naught x times cosine theta. And then the force is going to be negative and the derivative of the potential energy with respect to x. So it's going to be, we can plug in what we just got in the last part. So negative qd lambda over 2 pi epsilon naught x times cosine theta. And then these negatives are going to cancel out, so they are both positive. And then the only x we have in here is a 1 over x, so the derivative of that is going to go to minus 1 over x squared. Everything else stays the same because they're all constants, so this is minus qd lambda over 2 pi epsilon naught x squared times cosine theta. Now we can plug in the numbers. Minus the charge is 10 microcoulombs, so that's 10 times 10 to the minus 6. The distance is 2 centimeters, which is 0.02 meters. Linear charge density is 2 microcoulombs per meter. So that's, again, 2 times 10 to the minus 6 coulombs per meter. And then divide that by 2 pi times epsilon naught is 8.85 times 10 to the negative 12. And the x-coordinate is 25 centimeters, which is 0.25 meters. And then cosine of 35 degrees. And this comes out to around negative 0.0942 newtons.